Hi, welcome to Educators. In this video, we'll see predicting the house prices with regression. For that, I'm going to take the data set which contains the following features: year of sale, age of the house, distance from the city center, number of stores in the locality, the latitude and the longitude. This data set looks like this. It contains the year and the number of years old the house is, the distance from the city center, latitude, longitude, and the prices, and also the number of stores located near to the house. For that, the first step is I need to import a few libraries and the helper functions. I have imported the few libraries which are needed in my project. I have imported pandas, matplotlib, TensorFlow, etc. So to save time, I have already written the libraries which are needed. Now I'll press Shift Enter. I'm executing it. Once after completion of this, next step I need to do here is I need to import the data. I'm going to import the data into a data frame. df is equal to pd dot. I'm having a CSV file, so I'm using read CSV. Now it is located in my system under C drive with the name data.csv. Now I want the column names, so names equal to column names. So shift and enter. Before that I will see the output, what it is going to show. So I want to take header information. Yes, you can see the data with date, age, distance, number of stores, latitude, longitude and price. We have successfully imported the data. Next step is we need to preprocess. That is, we need to check is there any missing values present in the data. This is quite common in a real world data set. So we'll check that by using .isNA .sum. I want to find how many missing values are there. For that I am making use of the sum function. Shift enter. Now you can see no missing values are available in the current data set. Next, we should normalize the data. The reason of normalizing is here you can see the data of different variations. So to make it normalize or to scale in between 0 and 1, we are going to normalize the data. For that, I'm going to use df is equal to df dot allocate, which represents all the rows and columns, and df underscore. I'm going to make use of a variable name for normalization as data frame underscore norm is equal to, I'm going to normalize it df dot mean by standard deviation. Right, now we'll see the normalized data set by using this head. Now shift enter. You can see successfully we have normalized the data which are lying in between, the values are in between 0 and 1 only. Okay, right. Next, as we are using the normalized values for the labels, here the label price is a label feature, it is a label, right? Next, we need to get the predictions back from the trained model in the same distribution. So at the end we need to convert this to normal values. So for that I am going to write a function which is used for converting the prices, means the labels, to the previous distribution or to the original distribution. Right, for that I am going to take y underscore, as it is y, I am going to take it as a labels as y. and for that I am representing it as y underscore mean. Price is the name of the column, dot mean, right? Next, the standard deviation for what? For the same price we need to calculate, so STD. Now I'm going to define a function convert underscore label underscore value, and I'm going to pass the predict parameter. Now I'm going to return original values are of int data type, so I'm going to take int y underscore std plus y underscore mean. Now print convert label underscore value. We'll just check whether it is working or not. Value of, I will take one value and we'll check whether we are going to moving back to the original distribution, right? We'll take just minus, what is that given, 1836486. Now shift enter. Now there is some error here somewhere in print convert underscore label underscore value. Here I made a mistake, YD instead of STD I made STDD. That's the error. Now we'll check. Yes, it is giving as 12031. Now we'll see whether this is equal to the original value or not. For that we need to go back, and if you look at here the second one, because we have considered here the second price of the house, right? That is second row y value, that is price value. Here it is 12032. Now the output here we got is 12031. Because it is in fractional and we have taken only the integer, it has written 12031, right? We have successfully converted the label value. Now we'll see how to create the training and test set. For that we are going to take x is equal to df underscore norm dot iLocation. I need to consider only the values, means features. I should not consider the label. Here the label is price, so I am not going to consider that price. So I am going to take only the features apart from that price. So if you go for shift enter, you can see date, age, distance, stores, latitude and longitude. Actually your price should be the last column because it is a label here, but I am not going to consider that. So I have taken all the rows, only 6 columns from 6 columns. So I have mentioned like that. Okay. Next, I need to select labels. We have selected features. Now we need to select label. Label here is under what column? Under the column name price. So for that, y is equal to df underscore in the norm data frame. I want to locate only the label. So label is at the last thing. So I'm just taking as -1 and I'll see the output, how it is printing. Shift enter. Oh, I have given mistake here. Right, it should be dot. Sorry. Now you can see the labels. Now if you see, these are the labels, right? Next, we need to extract the numeric values from the features and labels, as the TensorFlow will expect just the numeric values as the input. So for that, I am going to take x array, that is an example variable here, is equal to just x dot values. Next, y underscore array is equal to y dot values. They are stored in x array and y array. X values in x and y values in y array. Now I'm just printing the shape of both the things like. So x array shape, what is the x array shape? For that shape is an attribute used, and also I'll go with y underscore array shape. So dimensions, right? Now shift enter. Now you can see x is of dimension 5000 samples, comma 6 and 5000. Y is a labels. It's a single row, single column with 5000 samples, right? Next is how to train and test split. First, given a data set, we need to, after preprocessing, we need to split the data so that some part is used, 3/4 is used for training and 1/4 is used for testing. For that, we are going to split the train set and the test set, right? Now here I am going to make use of a variable xtrain, comma x test y underscore train, comma y underscore test is equal to train underscore test underscore split x arr, the variables what we have given, y arr, which contains y values. We are going to mention the test size is equal to just 0.05, and we are going to give random state equal to 0. That's it. Next, we are going to print both the train set and also the test set. So x underscore train dot shape, I'll just print the shape of the training set and also the test set dot. Next, print x tst dot shape, comma y test dot shape. That's it. Now if you press shift enter, right here I made a mistake, it should be comma, it is given dot there. Now shift enter. Yes, you can see the size of both the train set and the test set. Earlier the original size of our feature vectors are 5006, and now it became to 4750 and 4750 y samples after splitting the data into train and test set, right? Now your test is of 0.05, so it is integer, it is represented as 250. So 250 samples here are used for testing, right? Next, we are done with training and testing of the data. Now we'll go with creation of model. For that, I'm going to use get underscore model. I'm defining a function, it is, right, a model. I'm going to use a sequential model. For that, I'm going to make use of this constructor, parameterized constructor, and I'm going to pass the values like dense of 10, comma input shape is 6, comma, and I'm making use of an activation function. Here there are many activation functions. Here I am going to make use of ReLU, right? Now here I am going to take this, that will be your input layer. I am going to take another layer, dense layer with 20 nodes, and here also I am going to make use of an activation function ReLU, right? Next, I'll make use of one more hidden layers. It will be 5 nodes activation is equal to again rel. It's up to you. You can give any activation function. And next, I'm going to tell you give an output layer with only one node. That's it. I have created a model, a sequential model, right? Next, I need to compile it. So for that, I need to go for model dot compile loss is equal to, here I am going to use a loss function, mean square error, and also we need an optimizer. I'm going to use optimizer, is equal to Adam. I'm going to use an Adam optimizer, and here I'm going to return model. That's it. Now we'll see the summary of it. So I'm going to call a summary function. So shift enter. Hope something I made again a mistake here. I have given a spelling mistake, sequential, right? It is sequential model, and here still something is missing here. Right, it is here somewhere. I have made a mistake here. Now if you press shift enter, you can see this is the model summary, right? So coming to this, here we can see the total number of parameters. The total number of parameters here, I hope you all know this, how we can calculate this. This 401 is the total parameters, the total count of this. And how we are getting these parameters is, you can see you can multiply 10 into 20, which gives you 200. And in addition to these things, connections, we will have in each node will have a bias, so plus 20, which gives you 220. Similarly, from this layer we have connected to this layer, which is having only 5 nodes. So every layer to every other layer, that is 20 into 500, and also bias, so 105. Similarly, 5 into 1, as it is having only one node and one bias, right? So total it is 6, right? I think it's clear. Next, coming to model training, we have created a model successfully, and now we are going to train it. Here I am going to make use of early stopping callback for stopping once there is no change in the loss. Okay, for that I am going to use something like callback function. I am representing it as CB. CB is equal to early stopping function used with parameters. I am going to take monitor is equal to, based on what, on value loss. So loss comma, I'm going to give another parameter, patience. Patience is equal to some 5 I am giving. Now model is equal to get model predicts and on is untrained. For untrained, I'm going to predict for the untrained data. So model dot predict of x underscore test. So it will give you random predictions. Okay, so next, history is equal to model dot fit. I'm going to train x train comma y train. I'm going to train my model y train, and validation data is equal to x underscore test comma y underscore test. And epochs, we can mention the epochs. How many epochs? Here I am going to take 100 epochs, right, comma, and also callback, right? What is that callback? Callbacks is equal to, I have stored that callbacks in CB value, right? Now we'll see. Now you can see it is getting trained, your model is getting trained, and here we are telling that to stop once there is no loss continuously, no loss in the sense no much change in the loss. And also here I have given one more parameter as patience is equal to 5. So instead of immediately stopping, it will wait for 5 more epochs before stopping the training. So I have mentioned patience is equal to 5. Okay. Now you can see this, it has stopped somewhere here, that is there will no change in that loss, so it has stopped. Okay. So next we'll plot training and validation loss. Okay. Now let's use the plot loss function to take looking training and validation loss. So for that I'm going to use plot underscore loss function. So just see how it works. Now we can see the graph. Blue line represents the validation loss and this orange tells us the training loss. Both somewhere at around 10 they stopped. They are going in the same way here. So after that still 5 epochs it went on to stop it training. So we can see that in the y-axis it is loss, and in the towards the x-axis it is telling about the number of epochs. Now we are done with training the model, right? And now we'll see the predictions, how they are predicting. Okay. Now for that I'm going to make use of a helper function called compare predictions, and before that I'm going to predict on what? On trained models. So I'm going to take trained model dot predict x. I'm going to send my test set and compare predictions preds on untrained, comma preds on trained. Okay, we are going to compare both the trained and we are going to plot them, comma y-test. We are going to predict y-test, right? Now shift enter. You can see here on an untrained model, you can see how it looks like. The samples are orange color represent, and these are your original y values, your housing prices. If you look into the trained model, they are very much near because the loss or the error is very much less when compared to the untrained model, right? Now coming to the price predictions as per our original values. Now if you look into this price and a score on, I'm just taking for untrained first. I'm going to use our function, helper function, which we have created above with a name convert and a score label. We have given a name convert underscore label value of what we are passing y. For y in spreads on untrained first, right? Now if you look by using the compare predictions helper function, I am passing both a price of untrained and price of trained for comparison. Untrained comma price on trained comma price underscore y y test, right? Now here I have just taken y test, right? Now if you press shift enter, you can see here a mistake here. Okay, spelling mistake here. Convert, I have just wrote as cover, convert is again convert. Now you can see here both on trained, if you're comparing the prices here on the predictions of both untrained and trained sets, you can see orange represents an untrained model and green represents a trained model. After training, we can see the values are very much close to, with less error, very much close to the original house prices. Okay. So this is all about your predicting the house prices with regression. Thank you for watching.